Okay. Hi guys. Happy Sunday. Nice to see y'all. This is our December week 4. Funny how we are in December week 4, huh? Supposedly tomorrow is December week 3, sorry, week 2. And now suddenly we are in week 4. Okay. Hi Dylan. Hi Tisha, nice to see you. Hi Kavi, as usual, nice to see you again. And hi Joey. Wow, there's 4 today. I actually expected less. What about the rest of everyone? So your guys is not coming, huh? I don't think so, right? Well, if he comes, then I'll pop a champagne or something. Right, guys. Today what we are doing, we are revising on our chapter. Oh yeah, guys, we are doing chapter by chapter, huh? Okay, and in case you forgot, last week we did chapter 11. Okay, we did chapter 11, and yes, hi Kavi, how are you? And if you are from KK, my physical class, I think we did chapter 1 also, the microorganism one. Okay, so because my online class, I haven't gone that fast, so I need to kind of repeat a little bit on chapter 1. Hope you guys don't mind. All right, so let's go to chapter 1, shall we? Okay, guys, we're doing something easy today lah. We are doing something chill today since it's a Sunday, and I appreciate you, take the time to attend my class. Anyways, let's start with chapter 1, shall we? So if you're from physical class, okay, like both of you, Dylan and Tisha, I think I kind of did this last week, last Monday. So don't mind me. I'm gonna repeat this a little. Okay, so 3 nutrient broth. Okay, we look at the experiment again. Okay, I think both of you done this already. So the rest of you. So this is 3 nutrient broth, as you can see. So we have 3 temperature here. We have 5 degrees, and we have 37, we have 70. So as you can see here, 37 is when the nutrient broth is really cloudy. So what does it mean? That means bacteria love this the best. As you know lah, 30 something is like the bacteria's optimum temperature. They like the temperature best. And if you see 5, if you put something into the fridge, then the thing will be slightly cloudy. Only slightly cloudy because bacteria is not very happy. 70, when it's too hot, same thing as well. So that's what happens when you have the temperature being, 37. Okay, bacteria is really happy. So state the observation, guys. There are 2 things you can say here, or you can just stick to one. You can say at 37, nutrient broth is cloudy. All right, or you can say at 5 and 70 degrees, nutrient broth is only slightly cloudy. Okay, so my observation here is at 37, the nutrient broth is cloudy. I mean, sir, isn't this very obvious? It's already in the question. Yeah, that's the answer. Okay, because what the real question is, the next one. They ask you, what's the inference? Explain why. Guys, why is it cloudy when it's 37? Why is it cloudy? As I said just now, guys, why is it cloudy? Because bacteria is the most active, all right? Or you can say 37 degrees is the optimum temperature for bacterial growth. Okay, any of you here already in BM? Okay, I'll just say lah, 37 darjah Celsius adalah suhu optimum. Same goes to BM, suhu optimum untuk pertumbuhan bakteria. Okay, guys, are you okay? Where's Tabitha, by the way? Where's Tarun, by the way? Are they coming? I don't think so.
Tarun isn't joining today.
Sorry?
Tarun's not joining.
Oh, okay, cool. What about Tabitha?
Tabitha, I'm not sure.
Oh, okay. I would assume that's a no, I guess. It's okay. I'll see them tomorrow. So, okay. So 37 is the optimum temperature. So what's the constant variable? What are the things you don't change, guys? You are changing the temperature. The rest of it you don't change. Okay, you can say the type of bacteria, the volume of your nutrient broth, the type of nutrient inside, the type of bacteria, the volume of bacteria culture. So many things you can say here. Okay, guys, I'm just gonna keep it simple. Okay, ready yourself lah. Oh my god, here comes this thing again. Operational definition. Okay, guys, I'm just gonna straight give you the answer. Bacteria is a microorganism. So what do you see here? It turns cloudy, isn't it? That turns nutrient broth cloudy. That's all. That's all. Step 1, step 2, and step 3. Okay, step 1 is you write back what the question wants. Step 2, tell me what is it. Step 3, write it based on your observation. I have repeated this for 1,000,000 times. Okay. Should you need it, I will repeat it again. Okay. Not before me giving you some of my thoughts that why can't you write this even after like 20 times of us writing this. Okay, so suitable method to store fruits and vegetables, that's going to be a refrigerator. Okay, guys, question 2, it's almost the same thing. Just now we are using temperature to test how bacteria grow. And now we are using light intensity. As you can see, bacteria, they grow really well in the dark, and they don't grow so well in under bright light, because as you know, bacteria, they don't like bright conditions. Okay, this is why if you put your bread, let's say your bread lah, if you put it under somewhere dark, put it in somewhere dark, your bacteria is going to go bad really quickly. Okay, so sunlight is very important, guys. Sunlight is very important, especially for your room. If you don't want your room to be full of bacteria and you get sick all the time, so you need sunlight. Okay, so observation, you will see colonies of bacteria. Guys, you know what are colonies? You know what is a colony? Colony means these dots lah, these like growth of bacteria, we call it colony. So in the bright one, there's no colony. Okay, so one inference on the nutrient agar, in the dark, they want you to explain this. Why do you see colonies? Why do you see colonies? Because bacteria is active at low light intensity or in the dark. Yes, colonies form. Okay, you have to explain why. Because bacteria, this is like low light. They don't like bright places. Okay, this is why somewhere with a lot of sun, you don't get a lot of bacteria. Okay, one hypothesis for this experiment. So the lower the light intensity, the lower the bacteria growth. Okay, semakin rendah. Oh, light intensity in PM is called keamatan cahaya. This is a bit more technical. Okay, semakin rendah keamatan cahaya, semakin rendah pertumbuhan bacteria. Okay, so this will be a bacteria. This will be bacteria. Guys, do you remember what an algae is? Do you know what is an algae? Algae, we call them mini plants. They love the sun, right? Protozoa, we call them mini animal. They look a lot like human cells. They look a lot like animal cells. And funny enough, some of them, they do have chlorophyll. Okay, like this thing called euglena. I don't know whether you heard of this. You learned this before, one actually. This euglena guy, it's a protozoa, but it has a chlorophyll, so it can do photosynthesis. So, sir, why is it on algae? I don't know. The scientists, they just put it under protozoa. An animal that can do photosynthesis. That's weird, isn't it? Okay. Anyway, I'm gonna skip this. I'm gonna skip this because this is effect of light also, which is the same question. I'm just gonna skip. This one same question also. I'm gonna skip also. Okay, let's look at number 5. Let's look at number 5. Okay, this question did caught some of my students off guard when it came up for SPM a few years ago. All right, because we learned a few factors about microorganism, isn't it? What makes microorganism grow well? What makes bacteria grow well? Number 1 is the light intensity. Number 2 is nutrient. Number 3 is humidity, water. Number 4 is temperature. Number 5 is pH. Right? But if you look at this experiment, it's none of those 5. There's nothing about temperature here, nothing about humidity, nothing about pH, nothing about whatever just now we mentioned. Okay, but instead it is talking about penicillin here. Guys, what's penicillin? This is in your form 4, chapter 10, I guess. 10 or 11? 10, 11. Yeah, somewhere there. Guys, what is a penicillin? Yeah, what medicine is it? It is something that kills bacteria. And what do we call it? Yes, antibiotic. Good. Okay, good. That's good, Dylan. Okay, so no, it's not analgesic. It's painkiller. So this is an antibiotic. Okay, so what's happening here? Okay, you see, if I put, you know what's a filter paper, right? I cut a piece of filter paper. I dip it in water. I put it into the nutrient agar. You see, the bacteria still grows. I mean, obviously lah, you still see bacteria grow because distilled water is not doing anything. But if I put 5% of penicillin, can you see something starts to happen? I can see this clear region here. What does it mean? That means within this vicinity, within this circle here, all the bacteria got killed by the penicillin. All right? And surely enough, if I use 20%, the clear region will be really big. So what is it telling us here? So the higher the concentration of the antibiotic, the bigger the clear region, the more bacteria got killed. Common sense, guys, common sense. Yes, this is not one of those 5 factors, but more or less you should be able to tell what is it. Because you learn penicillin in Form 4. I hope you remember them. Okay, so state 1 hypothesis, I mentioned this already. The lower or the higher the concentration of penicillin, the bigger the clear region. Okay, or the lower the bacterial growth. I accept both. Okay, I accept both because they are the same meaning. So what's the guys? What is the MV here? What is the thing that you are controlling here? If you can write your hypothesis, you should be able to write your MV because usually in your hypothesis, the front guy, that's the MV. Okay, your concentration of penicillin. Okay, because you're doing it like 0, 5, and 20. Responding would be your clear region or your bacterial growth. Okay, yes, good. And then CV, guys, what are things you don't change? Like I said, we have 5 things just now. We change 1, the rest we don't change. Okay, up there got already one. Temperature, light intensity, pH, things like that. Okay, just choose any one of it. Guys, you just need one. You just need one CV. You don't need to go crazy here. Okay, okay. Oh my God, here comes it. Here comes again. Operational definition. Okay, this is my answer. You try to do it in your head right now. Okay, try to do it in your head right now. What are the 3 steps? Now here's the answer. Antibiotic is, okay, step number 1, a substance. Number 2, or a type of medicine, if you will. Okay. Number 3, that causes clear region or nutrient agar. Clear region or nutrient agar, this is your observation, right? Right? So is your operational definition like this? Yep, Kavi, what's up? Anything you want to ask? Like I say, temperature, pH, go on. Light intensity, all kinds of things you want to write here. Even type of bacteria, I accept too. Okay, guys, is your operational definition like this? Was it like this? Put in. Did you do it in your head? Huh. Guys, this thing, right? Since your Form 4, if you have been following me since Form 4, I have been repeating this thing non-stop, like 20 to 30 times, not even exaggerating. I've talked about operational definition for like 20 times. So if I repeat something for 20 times and you still can't get it, it's either you're not listening or you have some kind of learning disability. I hope it's not that. It usually is you don't pay attention, okay? That will be usually the reason. Okay, state the function of set P. Okay, guys, you see, we all know what's gonna happen when we use distilled water. But why do we still do it anyway? I mean, 5% and 20%, these two set enough lah. Why do we still need another set with distilled water? Isn't this thing pointless? But why do we still need it? Guys, why do we still need the first set? What is it for? What is it for? This is so that we can compare. Okay, we can compare. All right, so that we can compare the growth of bacteria. All right. In a humid place, what answer would that be, Kavi? You mean your CV, or you mean D? Guys, this thing, right, has nothing to do with anything. This thing is just like a baseline. You know what's a baseline? You know what's a baseline? Okay, put it this way, guys. Put it this way. You know COVID vaccine, right? You know COVID vaccine. How do they know it works? How do they know it works? Because they gave vaccine to they did the experiment this way. They gave group A water. They just inject group A with water without them knowing. And then they inject group B with the real vaccine so that they can compare what's their resistance towards the disease. And lo and behold, surely enough, the one receiving the real thing is better protected compared to the one that receives nothing or the one that just receives water. So why do we do the water one? Is to compare. All right. Or in a more professional term, we call it to act as a control. Okay, as a control. What's a control? A control is like a baseline when you compare it with. All right, you get what I'm trying to say here, guys? You get what I'm trying to say here, guys? Okay, let's just say, let me give you another example. Let's say now you are cooking curry. Okay, curry. You don't know how much salt is good enough for the curry. So you did one set with no salt, and then set 2 with some salt, set 3 with a shitload of salt. So only you can compare how do they taste without salt and with a lot of salt and with fair amount of salt. So that thing, usually when we do any experiment, we will have a control. We will have a baseline that has nothing to done that has nothing on it. It's just like an empty baseline for you to compare. You get what I'm trying to say here, guys? You get what I'm trying to say here? So this set here, yeah, it seems useless to you, but it's not useless. It is there as a baseline for you to compare, like how effective they are, right? Because if I just do this and this, you might be like, this is so unimpressive. This is only okay. But if you compare to this, this and this, now can you see the difference? Then now you will start to think, oh wow, this is actually kind of impressive because there's a clear area there. If not, you will just think, this is just the normal. No, it's not. This is the normal. Guys, am I making sense here? Do I make myself clear? I hope I did. Okay, let's move on. Let's move on. Guys, can you name me all these classes of microorganism? Oh my God, this is so easy. What is P? What is P? This is the thing that grows on your bread. Yes, fungi, good. What about Q? This thing is green. This thing is a mini plant.
Algae.
Yes, thank you. Oh, I got scared there for a moment. Okay. No, Kavi, that's the reproduction method. I want the family. What class are they? What is R? What is R? It's one of the most common microorganism. You actually find this thing in your Yakult. So this is a bacteria, yes. You find this thing in your Yakult and your yogurt. Okay. Or your lassi, if you will. Damn, I'm craving for some lassi right now. Okay, so S is your virus. Okay, cool, cool. What's missing here? It's protozoa. There's no protozoa here. Okay. So guys, how do they reproduce? Okay, this is a bit difficult. This question is a bit difficult because almost all of them will do binary fission, isn't it? I mean, besides virus lah, virus they're just kind of weird. All right. So we do the S1 first because we all know how virus will reproduce. They can only do it when they're in someone. You see, virus they cannot reproduce by themselves. They need a host. All right. If a COVID virus leaves your body, they will most likely die. Right? I mean, it takes a while to die, lah, but they will die nonetheless. Okay, that means if you know HIV, guys, you know HIV, HIV cannot exit your body, you cannot pass it to someone that way. Let's say you share toothbrush with someone that has HIV, you will not get it because once the virus leaves the body, it will die. It will not survive. So there is no need to worry. Okay, and then let's look at spore formation. Which one will do spore formation? There's only
P.
one that will do spore here. Yes, that will be your pea. That will be your mushroom and your mucor and things like that. Okay, as for Q and R, guys, so which goes to where? This both, they are reversible also. You want to do this or you want to do this, both are correct. Okay, because your Q and R, they will both do binary fission. They also both will do conjugation. In fact, guys, conjugation can be done by all three. What is conjugation? What is conjugation? That is microorganisms' sex. This is how they have sex. When they want to do sexual reproduction, they will do conjugation. It's like two bacteria coming together, they will exchange their DNA and then they will go away. So that's what they do. Okay. In fact, right, protozoa is this two also. Okay, protozoa will also do binary fission and conjugation. It's the same. Okay, next. Microorganism P can carry out photosynthesis. Of course, no. It has no light. Q can make its own food. Yes, because Q, it's your algae. R is the finest. Is it the smallest? Is R the smallest? No, it's not. Virus is smaller. Guys, a bacteria is like this. A virus is like this. Okay, a virus is much smaller. This is why when you sneeze, you are very unlikely to spread bacteria because it's too heavy. But you are very likely to spread virus because it's like very lightweight. It's like powder. Okay, it's like powder. Okay, and S can only reproduce in a whole cell. Yes, that's correct. All right, so bacteria needs a host. Next, guys, can you tell me what is this?
Protozoa.
Protozoa. Thank you. Yes, it's a protozoa. To be more exact, this guy. No, it's not a paramecium. Close to it. What's the friend of paramecium? It's called amoeba. Right? This guy. Guys, paramecium and amoeba, they are actually kind of kind of similar because you can find them both in rivers and any unsalted water lah, any fresh water lah, you will get amoeba and paramecium, and they are most of them are not harmful. Most, okay, because some amoeba they can kill you. Anyway, guys, I'm just gonna skip this because it's the same thing over and over again. Oh, right, guys, do pay attention to yeast. What is the function of yeast? That's all you need to know. Guys, what is yeast for? What do we use yeast for? For two things. Okay, for two things. And they are billion-dollar industries. All right, so number one, we use it for alcohol. Okay, we put yeast with glucose and we cover it. We take away the oxygen. They will start to do fermentation. Yes, and then you have bread. Oh, do not confuse. We don't use yeast to make yogurt. We don't use yeast to make yogurt. Yogurt, we will use something called bifido. Bifido. It's different. Okay. Bifido and lactobacillus. Okay, these two are what we've. You can find these two in your Vitagen or any yogurt drink lah. Okay, you can find these two things. Okay. What else? Oh, right. Guys, pay a little bit more attention in your nitrogen cycle. You know what? I'll talk about nitrogen cycle later. Okay, since we have a little bit of time here. All right. Yeah, I think I mentioned this last week also. Guys, pay attention to these two. Oh, we do the other two one, the simple one first. What is boiling? Boiling means we use hot water lor. So boiling water to kill microorganism. Radiation. This is when we use gamma ray or X-ray or UV ray. What do we use this for? We use this for our operating theater. You know, it's an operating theater, place where they do surgery. Sterilization means, okay, sterilize and sanitize is the same thing. That means when you sanitize your table, that also means you sterilize your table. It's the same thing. That means to kill bacteria, to make it clean. Okay, so the remaining two, disinfectant and antiseptic, they are both chemicals. They are both used to kill microorganisms. So what's the difference? What's the difference? Which one can you put it on your skin?
Antiseptic.
Yes, antiseptic, good. Right, antiseptic it doesn't damage your body tissue. Yes, this is for human skin. You know acryflavin, guys? Acryflavin, the yellow color stuff, you put it on your wound. Acryflavin. This thing lah. This thing. This is antiseptic because it won't hurt yourself. No, Dettol. Okay, what about Dettol? Dettol. Wait, Dettol has this. Dettol is anti. Oh, okay. Dettol has the antiseptic. Okay, the Dettol for your floor is actually disinfectant. Can you put this on your skin? Definitely no. Can you put bleach on your wound? You can try. Okay, so not only it destroys microorganism, it also destroys your body tissue. So when you drink it, you die. All right, and I don't know, guys, disinfectant, they smell kind of, yes, hydrogen peroxide, that's good. Hydrogen peroxide is like a type of bleach lah. Okay, did you know they use it to bleach their teeth? They will use hydrogen peroxide and then they will use a brush and then they will paint it on their teeth. Supposedly it will whiten your teeth. I mean, why do that? Your teeth is supposed to be slightly yellow, right? Guys, white teeth is not real. It's only real because celebrity they put ceramic on it. Your teeth is not supposed to be white. All right. So C is the same question. Okay, you can refer to it yourself. Okay, you know what, guys? Let's talk a little bit of food and technology. I do want to talk about. Okay, let's go to plants first. Let's go to plants first. If you remember, without nitrogen, your leaf will turn yellow. Without phosphorus, your leaf will turn purple. And there's one more, NPK one. If without potassium, K is potassium, without potassium, your leaf will turn brown. Okay, so this is what you need. That's all. That's all you need to know. This is the macronutrient of a plant. What does it mean? That means they need it a lot. They need a lot of nitrogen, they need a lot of phosphorus, and they need a lot of potassium. The rest, like calcium, magnesium, all those, they just need it in small amounts, so it's not too crucial. Okay, but they need this three. All right, I'm just gonna skip this. You don't need me to mention about nutrition, you learn this in Form 2, but I do want to talk about this. Ooh, do you remember this? What is the big cycle and what is the small cycle? The small cycle is within the soil. The big cycle is between the soil and the air. It goes up and down. Okay, guys. Wow, this is difficult, huh? All right, so label with the type of bacteria, guys. There are two ways they can ask about this. Either they ask you the process or they ask you the bacteria. I don't care, it's the same either way. Okay, guys, remember the USD in your soil? Remember the US dollar in your soil? Why is nitrate a US dollar? Because nitrate can be used by every plant. Nitrate can be used by every plant. That's why it's the USD. It's the universal nutrient. Every plant can use this. So how do we convert this thing into the air? How do you convert it out? How do you throw it out? Okay, you know what, guys? Let's talk about R first. How do you change something into nitrate? How do you change ammonium into nitrate? You nitrify the thing. You get what I mean? You get what I mean? So Kavi, that one is P. I hope you mean P. Okay. If something has no color, you colorize it. Okay, something like that. If the school is ugly, you beautify it. So if you want to change something into nitrate, you nitrify it. So this process is called nitrification. But they don't want this, they want the bacteria. So the bacteria is called nitrifying bacteria. You just change this into continuous form. Yes, nitrifying bacteria. That means you change this into this. If I change it away, I change it to here is nitrification, I change it away is denitrification. Remember? So it's denitrifying bacteria. It's the reverse, right? I activate something and I deactivate something. I colorize something and I decolorize something. Works that way. Okay. And how do you convert it back? How do you convert it back? It should be like, okay, guys, it should be this way, isn't it? You see? So since this is D, right? The reverse should be called nitrifying, isn't it? It's like reverse, but I'm sorry, it doesn't work that way. I know, but I'm sorry, it doesn't work that way. Okay, nitrification is in fact this. Okay, so how do we do this? Okay, I give you a hint. I'll give you a hint. This nitrogen cannot be used. I need to fix it. That's a big hint right there. I need to fix it. Yes, it's a bacteria. What is it called? I need to fix the nitrogen. So this process, yes, is called nitrogen fixation. Okay, and the bacteria is called nitrogen fixing bacteria. There you go. All right. I hope it goes without saying, guys, these three processes is the bread and butter of this nitrogen cycle. You have to, and I regret to I'm regret to inform you, you have to memorize them all. Okay, I don't know lah. For me, this is not too difficult, isn't it? Okay, this is the big circle, big cycle, and this is the small cycle. Because small cycle is just within the soil. All right, guys, what is S then? This one, nothing really to do with the nitrogen cycle. It's just when plants die and when you die, you turn into ammonia. What is this? When you die, what happens to your body?
Decompose.
Yes, decompose. Good. Okay, so this is decomposition. Okay, so this is decomposing bacteria. So if you pay attention, right, this thing has nothing really much. It's not really nitrogen cycle. It's just part of what we do. Okay, but the main point is this. All right, remember, you nitrify something and then you denitrify something, and you have to fix that nitrogen in the atmosphere. You have to fix it. Okay. As I said, guys, don't focus exclusively on something, because even if this comes out, it might be just an objective. So you can just, I really hate to use the word temba lah, because I really hate temba. It's just lazy, right? You can guesstimate. You know, it's guesstimate. That means you teka lor. But teka with some kind of hint, not just buta one. Like you know what's up mostly. That's all I want you to know. Okay. You don't need to go crazy here. And then name the process. Okay, the process as I mentioned here already lah. Nitrification, denitrification, nitrogen fixation, decomposition. All the shen one is the name, and all the ing one, denitrifying, nitrifying, nitrogen fixing, decomposing. All the ing one is the bacteria. No, if they ask for the bacteria, if you write the process, you will lose the mark. Even if, sir, isn't nitrogen fixation and nitrogen fixing bacteria the same? One is the guy and one it's the action. Do you think it's the same? It's not, isn't it? Okay. I am Eddie. I am a tutor. All right. I am tutoring. Is it the same? You see, tutor is my job. Tutoring is what I do. Okay. This is like grammar. Okay. So I'm sure in exam you can figure it out. Okay. I'm not worried. Okay, so nitrogen-fixing bacteria are found in the root nodules of a plant. What is the type of plant? The plant, we call it legume plants. What are legume plants? You have your soy, you have peanuts, anything that grows underground, bacteria will live there, and they will change the nitrogen in the air into nitrate. Okay, two importance of nitrogen cycle. Number one is to maintain nitrate in soil, or we can say soil fertility. Okay, kesuburan tanah. Because you see, if there's no nitrogen cycle, if I finish my nitrate, my soil will be useless. Guys, any soil without nitrate is like useless soil. Nothing can grow there. Right? And what's the importance? This is for us to or you can say maintain nitrogen in air. Okay, which is that 78%. Guys, 78% is our nitrogen in the air. Legume plant name in C. So what plants do you want? Oh, you mean peanut and those but they want the type though. I mean, if you give the name of the plant, you might get away, but I wouldn't risk it lah. All right, so natural phenomena that has the similar role of nitrogen fixing bacteria. Okay, guys, what is in nature that can replace this? That's something. What is it called? If I don't want to rely on these bacteria, what else can I use? Yes, good. Lightning. Very good. Okay, lightning. Lightning is also bacteria. Is also nitrogen fixing. But of course, guys, we will never rely on the bacteria. We will also never rely on lightning. Modern times anyway. Why? Because they are too slow, like freaking slow. Okay, this is why we use fertilizer. Okay, Haber process already done this for you. Remember Haber process? That's why he got a Nobel Prize, because he Okay, he made this to be fair, not this, but it's the same. Okay, there's no need for you to rely on lightning, no need for you to rely on bacteria, because if we rely on them, we will starve and we will die of hunger. Okay, I think I mentioned this like many times already. Extract nitrogen. You know what? This is the same question. I'm gonna skip this. All right, guys, go home and practice your nitrogen cycle. I'll leave this to you. Okay, what's the tricky part about this nitrogen cycle is, can you see the shape changes every time? This one is like this, and then this one is like the other way around. Okay, but don't be scared. Whenever you see nitrate, you can split it into two. So nitrogen is in the air. This is the air cycle, the going out one, and then this is in the soil one, the soil cycle, the small cycle. So you have the small and then the big one. Just say lightning will do. Just say lightning will do. Lightning is going up. Okay, same thing, Same thing, Nitrate, we split. So this is in the air, because nitrogen, and then this is in the soil. That's all. That's all. Really simple. This food technology stuff, I will just skip lah. Oh, this one. Guys, what is pasteurization? This is really important. What is pasteurization? And where do we use it? What kind of food uses pasteurization? Yes, milk. Okay. We don't say boil out, we heat it. Okay? We heat it to 72 for 50 seconds or 63 for 30 seconds. And then we cool it. Guys, again, the best thing about pasteurization is the nutrient retention. Okay, the nutrient retention. We can keep most nutrient. You cannot boil milk, guys. If you boil milk, you're going to break down the vitamins and the nutrients inside, and it's kind of junk now, right? Guys, if you boil the hell out of your milk, you actually spoil it. Okay, this is why we pasteurize it. Okay, and fruit juice is the same. So I'm just gonna, do the easy one. Freezing is below 0. Okay, it's actually -17. Vacuum packaging is airtight. We use this for rice. Okay, guys, we can't do vacuum packaging for your potato chip. Like I said, why is our potato chip, the bag, so damn big and so damn full? Are they trying to cheat our money? No, actually. You see, if you buy Lay's, okay, Lay's is like is notoriously famous for that. Guys, inside your chip, you have nitrogen gas, okay? And that thing sort of acts like a cushion, so that when they transport, they don't break your chips, okay? Or else it's gonna be really annoying, because when you open your bag of chips, your potato chips, it's gonna be all broken. Okay, so yeah, it's not like they want to cheat your money lah. They did write the mass in front, so it should have that amount of chips. All right, so irradiation, this is when you use radiation, as we say. Okay, so this one we use gamma ray, UV ray, or X-ray, any ray lah, any dangerous ray. Fermentation is we use yeast. Dehydration, we remove water. This is the oldest way to preserve food. We put it under the sun. And of course, canning is we store it in sterilized can. Okay. The good thing about canning is it lasts for a very long time. But the bad thing is you do lose a lot of nutrient. Okay. This is why your mom says canned food is not healthy, because it really isn't. All right. I mean, compared to real fish, you would rather eat real fish rather than like tuna, canned tuna. Okay, first of all, it's really dry, and second, it's not as nutritious as the real thing. But then again, guys, tuna is really expensive. Okay, so this is why we only use the canned one. We don't really use like raw tuna, do we? You can only find that in sushi or sashimi restaurants, and it's really expensive. Okay, guys, I'm gonna skip this. I am going to skip this. Oh, do memorize what your food act and food regulation is. Really important. Food regulation requires us to put food labels. And what should be on the food label, you should know. Okay, not the halal logo, guys. I think this thing has been asked for so many times. The halal logo is determined by JAKIM. And who is JAKIM? The body that regulates Muslim food. It has nothing to do with us, right? Even if it's non-halal, we are like, okay, cool, nothing to do with us, right? Hey guys, extra info for you. Halal is not about having pork or not. Sometimes you say, hey, why is the chicken halal? Chicken got pork, man? Because that's the Muslim way of slaughtering, and that's the non-Muslim way of slaughtering. If you slaughter chicken using a non-Muslim way, which is full of torture, it's non-halal. Okay, so this is like their hadith lah. Okay, it's like their what their Bible says. You have many things, halal and non-halal. Okay, let's go to chapter 4. I'm gonna skip 3. Oh, guys, chapter 3, Form 5 chapter 3 is really similar to Form 4 chapter 4. It's about the environment. It's about carbon footprint, handprint. It's about fossil fuel. It's about energy efficiency, right? So these two chapters, they are very related and they are very much about KBAT. So if you're someone that knows about KBAT, this is like a godsend chapter to you. However, if your KBAT is not too good, yes, this thing will just slaughter you. So do read a lot of this. Okay. Any question before 20? What do you mean? Oh, you mean page 20? You mean page 20? Why? What's up? I did you remember our Wednesday class? That's where we last left off the graph one and the question 20. Oh, you mean this? No. Oh, you mean before question 20? I did some lah. I did some. The graph one I didn't do. I did like the inertia one and yeah, the ticker tape one. Remember? That's all. Right, because I really don't want to repeat, similar stuff again and again. Because you can do it yourself actually. All right, for the last part, let's go to chapter 4, shall we? Let's go to chapter 4. I'm jumping around, guys. I'm jumping around because I'm trying to cover as many as I can. Oh, again, guys, again, should you need any chapter, should you need me to repeat any chapter, please WhatsApp me instead. I will send you the video instead. That will be easier. That would be easier. I want you to WhatsApp me. Let's say, sir, I need videos for chapter 6. I will send you the whole chapter 6 and you go and revise it yourself because I really don't feel like repeating. It's very time wasting because this thing I've taught it before and you can do it yourself by looking at the videos again. What for I repeat it in my class? Might as well I spend some time doing some questions like these to make you know more, to make you able to answer. Okay, I hope you get what I mean. So let's look at chapter 4. If you remember what is a rate of reaction, we have rate of reaction means the speed of a reaction. If the rate is high, that means the reaction is very fast. If we have low reaction, that means the reaction is very slow. Okay, so photosynthesis is slow. Metal, carbonate, and acid, when you see acid is mostly fast. Combustion is fast. Fermentation of alcohol, making alcohol is slow, like really slow, takes years. Reactive matter and water. Reactive, this matter is crazy, so it's fast. And rusting is slow, painfully slow. All right, so guys, do you remember what is this? Hey, did any of this come out during your trial? Not really, isn't it? Did they ask you to draw this graph in trial? Not that I'm aware of, isn't it? They didn't, see? That's why I say this chapter and electrolysis, since they are from chemistry, they have low chance of coming out. Low, I didn't say it's 0, it's low. All right, so you don't need to go crazy here. Okay, guys, if we remember, we have 2 ways of finding rate of reaction. Okay, we have the calculation method and we have the graph method. Of course, calculation is easy and fast, but it's not accurate. Graph is very tedious. You need to draw this, the tangent, remember? You need to draw one tangent line, then you need to get the gradient and things like that, which is very time consuming. But the good thing is it is very accurate. This is not accurate, this is very accurate, right? But the main downside is it's really troublesome. You need to draw a graph, then you need to draw that tangent line. If the tangent line is not nice, you're not going to see anything. Okay, things like that. All right, remember we did this in class, and I walked around and I checked all of your answers. That chapter. Okay, so we calculate A. Okay, let's do the calculation method first, the easy one first. The overall rate of reaction, this one very easy. So you see where it stops? 0, 20, 30, 39, 43, 45, 45. So this is when the reaction stops. Not here, not here, because here they already collected 45. Okay, so the overall rate of reaction is just 45 divided by 150. We get 0.3 cm cubed per second. Okay, guys, this number is the easiest to calculate, but it has the least meaning. This number means nothing, right? Does it mean your rate of reaction stays at 0.3 throughout? No, isn't it? Rate of reaction is really fast at the beginning, slows down as we go, really slow as we go up. Isn't it? So this graph, this number, it means nothing. It's just like your average mark for your exam, right? Let's say your burrata is like 60. Does it mean you score 60 every subject? Does it mean you are equally good 60 everywhere? No. You could be very good in math, like you score 70 there, and then your pendidikan seni, you just kind of suck and you get like 30. Right? But so this 60 doesn't mean anything. It's just like average marks. Okay, so this 0.3 is just like the average rate of reaction. You see, average, it means nothing. It's a meaningless number, right? But if we calculate the first minute, this is slightly better. First minute is when? First minute is here. So 31 divided by 60. Second minute is here. Guys, remember to minus off the first minute, because second minute means I want from 60 to 120. If you calculate the whole thing, you straight away take the 43 divided by 120, that is 2 minutes. Because you take the whole thing here. All right. If you want the second minute, that means I want only here. So you have to minus off this one in front. So you should go 43 minus 31 divided by 120 minus 60. Something like that. Okay. So this should be 12 over 60, which is like 0.25. Is it? Or 0.2? I think it's 0.2. Okay. So guys, if you split this into the first minute, second minute, and the third minute, your graph, instead of looking like this meaningless graph, it would look something like this. Is this good? It's okay, right? I mean, it's better than this lah. But you see, there are like points here. Of course, this is much better. But this is troublesome, lor. You see, the more trouble you go, the more accurate you get. If you try the simple one like this, it means nothing, right? And this is the worst. This is the worst. At least this one splits and tell you, oh, which subject you do good, which subject you don't do good. This is like every detail. Which subject, which section, how many marks you get, what did you write. This is like really accurate. This is like halfway. So guys, I mean, it makes sense lah. The more trouble you go to, the more accurate result you get. The easier it is, the more meaningless it is. Okay, of course, I'm not gonna do this lah. Okay, you have to like, okay, what is the rate of reaction at the 60th second? You have to draw all the way up here, if you remember, and then you have to draw this tangent line. Oh my god, I can't draw. Okay, I don't have a ruler here. You have to draw this tangent line, and then you have to draw this triangle. You have to calculate the y2 minus y1, x2 minus x1. a lot of trouble, as you can see. Okay, but it's accurate. Okay, but it's accurate. So depends on the question, lah. Guys. Let me just say, this thing, right? I don't think it has appeared in SPM before. Same goes to electrolysis. Does it mean it won't come out this year? I don't know. It might not. So I don't know. Just be prepared, lah. That's all I'm gonna say. Okay, so guys, don't worry. This one I will repeat in my physical class also, and my next week normal class, which is our week 2 class. So you guys okay? You guys okay with everything? Any question you wanna ask? Guys, this is the time to ask. I'm repeating every chapter as I can. So if you have any question to ask, please do. Okay? Any question? If there's no question, I think I might call it a day. Guys, it's a Sunday and you came. I appreciate it a lot. Okay? And I shall see you, some of you tomorrow, and some of you Wednesday. Okay? Have a good Sunday, guys. Have a good Sunday, guys. I will see you soon. Okay, take care.
Thank you, teacher. Bye-bye.
Bye-bye.